Hello friends, today I will show you how to prepare index layer for creating data-driven pages in ArcGIS. As you all know, there are 77 districts in Nepal. If we wish to prepare 77 district maps in A3 size paper in a standard layout, we can use data-driven pages toolbar facility available in ArcGIS. Actually, data-driven pages gives us the ability to generate a set of output pages by taking a single layout and iterating over a set of map extents. The extents defined by the features in a layer, in our case the district layer, and are sometimes called tiles, sections, or areas of interest AOI. The layer that defines the extent, like in our case the district boundaries, are referred to as an index layer. In our case, this layer, which we know that it is district underscore area, is called index layer. We create and customize new data-driven pages using the Setup Data-Driven Pages dialog box. In this video, we will create an index layer called districts underscore area underscore index and calculate map scale for individual districts. Friends, the sizes of the districts are not the same. That's why when we create map in A3 size standard layout, the map scale for different districts will change based on their total area or the length and the breadth. So we should keep this in mind. So that's why we try to calculate map scale for individual districts. The basis for calculating the map scale is the height of the rectangle, height or width of the rectangle, which can just enclose the district. In ArcGIS, this can be done with the help of minimum bounding geometry tool. So our plan is to prepare a set of maps for all districts in A3 size layout. It shows roughly the layout, and the map frame is approximately, the width is 27.7 centimeters and the height is 29 centimeters. So in order to perform these tasks, we will have first of all to create a geodatabase and define its projection. In the future projection, we are planning for the district maps. So in our case, it is Olbers equal area conic projection. For this, we just open ArcGIS 10.8. In my case, I define the projection system for map frame, and we are going to use Olbers equal area conic projection system. Apply it. Okay. And now in this data frame, we add our district layer. Let us see. So this district layer is in average decimal degree system. Now we add it into this system, and let us convert this layer into our new database. So we first have to create new database in our practice folder location. Here is the practice folder, and inside it we have different folders and geodatabase. Here we can create new database, new file geodatabase, and rename it as rename it as practice say practice Olbers equal area conic projection. Yeah? For understanding only, we create this, and inside this practice GDB we create new data set, feature data set, and let us call it administrative and define the projection system as Olbers equal area conic projection. So that's it. We already have this system here in place, and now we convert this district area layer, which is in average decimal degree system. We can check it here. So average decimal degree system here. We can export this data to our new system. New system means, so we have a practice EAC database. We save it inside this data set and call it district area. District underscore area underscore is going to be index layer index, and save it. So we have saved it, and now let us add this layer to current ArcGIS data frame, and let us remove this one. So this is the district area index layer, and if we go inside the attribute table, we have these attributes here. Now we are going to create rectangle boxes for each and every district, so that we can calculate the future map scale for each and every district. So it is done through this mechanism. Let's go to find the required tool, which is in so let us find the minimum bounding tool. It is under this toolbox. Click toolbox. Now we go to data management tools, and go to features. Let's go to features, and here we find it, minimum bounding geometry tool. Let's double click it to open and give the input layers, this one, and there are different options for creating, and let us save it in our folder. So let us save it as it is in our folder. We district area minimum bound, we can copy this name, and let us save this file in this location. Okay, and the geometry type should be envelope. That means the rectangle which are going to be created will include each and every district. So grouping, we can leave it as it is, and we can click this to add geometry characteristics as attributes. That means the width and the height of the rectangles, and let us click it. OK. So after processing, it's quite a fast process. So now it is done. Just to see what has been created, we just change the symbol outline symbol also. So in this way we have created 77 polygons, each polygon covering a district. So now if we go inside this attribute table, we have different attributes here, out of them we are looking mainly for this minimum boundary geometry width and length. These are the most important things we need for our future layer. So now we have for each and every district, we know the width of the district and height of the district. So now in this layer, we add a field. We add a field. Let us add a field and say this field maybe the bigger one. Maybe it may be length or width, whichever is bigger, we record it in this field. So we record it as maximum, MAX, maximum value. So this value should be float for type and click OK. So now here we find out which one is bigger value, whether it is width or length. So for doing this, we calculate using field calculator. We calculate the maximum. It is done like this. We go click Python, and the Python formula is maximum of, we put this symbol here, maximum of width, okay, maximum of MBG width and length. Yeah, with this formula we calculate the maximum value among the two values, MBG width or MBG length. Click OK. The maximum is calculated. For example, this is 71,530 is bigger than 53,000. So the maximum value has been calculated. And as we plan to prepare our map in A3 size paper, whose this map frame size is 27.7 centimeters and 29 centimeters. So let us use this smaller value to calculate the map scale, because if it fits with this value, it will definitely fit with this value as well. So here in this, we add another field and let us call it scale. Let us call it scale. It should be scale should be large, maybe double, or okay, it is long integer, maybe long integer. Okay, so now for calculating scale, we use field calculator, and so let us find it like this. So scale can be calculated by, first of all, we multiply this maximum. So okay, let us use not Python, Visual Basic script. Let us use, we use maximum multiplied by 100 to get the centimeter values. So this maximum value in our field, they are meters. So to get centimeters, we multiply it by 100, and then we divide it by 27.7, so that this gives us the 1 centimeter in our database or the map. The equivalent of 1 centimeter in database or map in the ground, that is the scale. So let us click OK, and it gives scale. This is the scale, but it is not the exact value we are using for the map scale. So let us improve it a little bit. So once it is calculated, this scale, we divide this value by 1000 and get the integer value of this, integer value of this. Okay, integer value of this. integer value of this. Then we multiply this integer value by 1000. No, first we add a value plus 1 integer value plus 1 and multiply this value by 1000. So this way we'll get the map skills divisible by 1000 and 1 greater than the calculated value. So let us see. So this is what we are looking for. See, so this is 259,000, yeah, and it is these are the more practical numbers for using as map skills. So in this way we find out the map skills for each and every districts. Now what we can do is that we can transfer this value to district area index. For doing that, we first go to district area index table. This table, it doesn't have map skill as of now. So now we join. So first we open this table and convert this table to export a table to a new table. Okay, all records, and let us put the tables out. Export output administrative. Okay, let us check and add as table. So it's not done yet. So let us try to match this way. Open here, we can join it like this or not. So okay, maybe possible. We join the table attribute table of district area index on the basis of this district ID with the attribute table of district area index minimum boundary. This file on the basis of district ID, keep all records. Okay, click OK. So now the content from this district area minimum boundary layer has been transformed, joined to the district area index. So now we have district area index. Now to make our life simple, let us convert this file district area index, which is in Albert's equal area projection system, and transform this data, export this data to our original the practice folder administrative data set, and we keep it here, district area index, and save it. Okay, checking we added here, and let us remove all these things. Now let us check this this file is source. Now the system has been changed, average DD changed to average decimal degree system. Okay, and if we go inside the attribute table, we have the scale information here. So we can just safely remove all these unnecessary fields. We can remove it. So it also here also remove. Unnecessary fields to keep our data simple as far as possible. So this system generate cannot be remove. We just turn it label. So this is our final index, district area index layer to be used for making district-wise map using data-driven facilities available in the ArcGIS. So that's it. In next video, we will see how the data-driven pages are used in combination with this district area index map to prepare district-wise maps in a few minutes. Until then, thank you very much. See you in next video.